Okay, let's get it started. And today's class, you guys are supposed to read this, right? Type of processes. Okay, and this is really important because most of the part in the earlier part of the class, I focused on the processes. Um, you know, there are a variety of types, and these types of processes are actually determine what kind of manufacturing system you are dealing with. And there are a very good reasoning behind of it. And I mentioned that the product you produce and the characteristic number of unit and the blah blah blah, all these characteristic of products are actually determining fact of what kind of processes and what kind of the group of processes are best for your production system. In order to truly understand that one, you first know the type of processes, right? So, according to this reading assignment, there are a variety of types, and it is not clear-cut. There are, this is 100% this type of processes, and that is 100% that type of processes. It is really, really hard to clear-cut the two different processes. There are always the transient spectrum between everything, but you got to know the very basic basis of these process types. Okay, what did you read? What kind of processes are there? Project, job shop, job shop, batch, line flow, continuous process. Anything other than that? Based on this reading assignment? Okay. It is intentionally ordered like this. Can you explain based on what characteristic do you categorize the process into these five?
It is divided into the size of order.
Size of order.
And in addition, the demand type.
Demand type.
For example, some customers demand quality, but some customers demand want to the quantity of the material and ordering.
Okay. And any other things? Price, yes. And what's the baseline of, you guys are talking the correct thing, the price, the units and all other things are the characteristic of products which which can be used to explain the characteristic of these processes. And what do you think the very basic of that differentiation?
So, I asked you what is the difference between all these
No. What I'm asking is, there are this type of spectrum, different processes, and people choose one processes out of this spectrum to produce their own product, right? I'm asking why.
So this is because actually the product they are actually producing from this process is not actually the same in all these places. When we actually producing in a lot, we will go for batch process. When produce a unit turn, we will go for project.
Yep, that's correct. 100% true. Why? Once again.
The demand is different.
Okay, demand is there. And because that is most economical to do that. Nothing more than, you know, bottom line is we are doing this because we want to make money, right? Minimize the input, maximize the output, blah blah blah, right? You know, you can produce sugar, for example, which will be best produced by this kind of process. You can produce a sugar with job shop or project. Why not? In earlier time, they produce maybe in batch or job shop, right? They build a big jar of boiling water and you put some raw material and do that, and after that you bring that jar into the next station and do another thing and eventually make a sugar, right? They did. So it is technically feasible to produce a product with different type of processes. But nowadays people definitely choose that one for the sugar production. Why? Because that's most economical, right? But in earlier times, people use another things, okay? Why? Because at that time, maybe they don't have enough technology, enough equipment, or something like that. That's true. Is it also true in nowadays? Yes, yes. If you don't have enough technology, then even though some advanced country in some advanced country, people use line flow to produce something, but we don't have enough technology, then we have to take job shop or something like that. It is true. Can you think of any example, very good example of that kind of thing? Think, think, think.
I think it's rice produce.
Rice produce.
And our country, it produced when it produced separate rice and
Yeah, I know what you mean. For example, rice field. When you're harvesting the rice field, some advanced country, Korea as well, they do have machine to do that. All you have to do is drive through it. Everything is automatically produced down there. It's a kind of line flow, similar to line flow, but in underdeveloped country, people have to line up and do everything manually. Well, batch maybe. So something is happening right now, always happening. Okay? For example, when Toyota make Toyota production system, their ideal production line is Toyota production system, their own name. The ideal state is that they do only have one inventory, one unit of inventory to pull the downstream, to pull the upstream and trigger, give the order to the upstream workstation. That's it's more like a continuous process. But in most of the automobile assembly line, it's a line flow, disconnected line flow. The difference of the Toyota and the other rest of the automotive company is it actually pulling continuous flow line or disconnected line flow or something like that. So technology and equipment, all other things can actually prevent you to choose best possible production system. Okay? Even though we know that's the most economical thing, but we cannot sometimes. Okay? Because of the technology barrier. Okay? But most of the time, when we're dealing with the production systems engineering, we assume that we don't have any technological barrier. Okay? That's one thing to consider. And the other thing, I'd like to just expand your horizon. Since we are the engineers, so mathematics matters, rules or computer program, algorithm matters. But sometimes that's not all in production systems engineering. There are very famous examples like this. Have you watched the TV show Undercover Boss? You don't watch TV, you always study. It's some reality show. The top level CEO, the face of a top level CEO is, not that famous. If you're the cashier working for the Burger King, you may don't know who is the top management. So this kind of top management guy just in undercover apply for a job as a cashier and do the work and all kind of TV show, reality show. Same things happen, and it is actually reported in the academic literature. Some high-level CEO are very interested in increasing the productivity of some assembly line, and their company have several assembly lines, so they pick just one randomly. It's a natural process. In order to do something and make change in their own assembly line, they want to look more detailed way by choosing one line and check everything, what's the problem, what's the difficulties and other things. Okay? Then, in reality, what happened is the productivity of that specific line just increased, almost doubled. The top level CEO doesn't do anything. But, on the line, people are working to assemble something, but people heard that top level CEO got interested in our line. And it boosted the morale of the workers, and suddenly the productivity increased 2 times. Those things can happen very, very frequently in production systems. But to make a problem simpler, we ignore those kind of human factor out of our equation. But human factor is really, really important and plays a very high portion of this production systems engineering. Okay? Also, by choosing these types, I said it's for the money, best possible. And the other thing is the culture. Okay. Sometimes, I don't know, but for some specific culture in um, some specific country, some of the type of processes are not acceptable culturally. Can you imagine that? It is true. It's very hard to imagine, but some of the in some cultural system, um, you know, it's a very I have to very careful. You know, in your cultural system, people have to pray 5 or 6 times per day, 5 times in very specific, time. The time is given. Okay. For those kind of cultural system, your assembly line has to stop. Okay. What if the assembly line can be stopped, paused sometimes, but what about this continuous process? Um, for example, except the very highly automated system, because everything is running automatically, but sometimes this continuous process should some of the continuous process, the human interruption is essential, but in some cultural system, every 3 hours or so. I don't know, but
Actually, 5 times a day.
yeah,
But
5 times of every.
about between 9 to 5, actually the office hours.
Yes.
Actually, there is only a 10-minute gap during the lunch break. That is the break.
Oh yeah, yeah. So sometimes to make a factory there, you have to put special consideration. So for some time, it should, that is what I. So human factor, cultural factor is important. Even though we are neglecting those kind of effect for the simplicity purpose in these courses. But keep that in mind. Um, you know, oh, I learned this big, nice equation, and I'd like to apply this equation to everybody because it's a perfect, but it does not work. Okay? Have to think about the human factor, cultural factor all the time. Okay? Okay. Um, okay, in terms of labor, what do you think about this spectrum? If you go to the bottom line, it is more easy to automate, but if you go to the project, it is more hard or difficult to automate. So human intensive labor intensive work will be frequently found in this era, but not here. How about materials? How about the supplier, material flow, and the like? If you go to down here, it's more certain. But if you go up, uncertainty increases. How about the planning and control? What do you think in terms of the planning and control? Which one is hard to control or hard to plan? Continuous process. Why is that?
Actually it's going on and on.
Yeah, if you make a mistake, you will, ruin everything. That's a good point. And what do you think? Usually, a continuous process is for the mass production. So, you don't have to think much about the variability in demands. But in job shop and batch, there is a higher variability even compared with the project. So, higher variability, higher planning and scheduling control required. What else? What else? Okay. To motivate you a little bit more, do you like cars? What kind of product do you like most? Yacht? Car? Car? Okay. What is your dream car? How does it spell? It starts with L or?
Lamborghini.
Lamborghini, yeah. L. L-A-M. B-O-R. G-H-E-I-N-I. Okay. Lamborghini. What's your dream car, Minso? Ecos. Okay. UUS, I think. No, you don't. You have to choose another thing. It's for the class example. So. Porsche. Porsche. Am I right? Okay. Mohammed. Jaguar. What? AR. Okay. Um, okay. You're meaning a specific model in Lamborghini, right? Okay. Do you know how much those specific type of Lamborghini is sold in a year? Guess. How many? Guess. Maybe 10 or 100 or 50, 100 per year. I think it's too much. It's a really, really expensive one, right? Am I right? Okay, let's make it 500 then. It costs, well, 10,000 maybe, or more than that. 1,000? 2,000? Porsche.
So 500 per year or maybe less.
Okay. 300, I guess. Jaguar. 500. Spectrum is not so good. Let me bring some example. Have you heard about NASCAR? North American stock car race. So it's for the racing, NASCAR. No? Have you ever heard of any type of racing, car racing? F1, okay. F1 Formula. Maybe it's one, right? Because it's a, you know. Okay, Lamborghini is good. So number is similar. So let's cancel these two out and let's bring some more popular thing. Sonata. Maybe, I don't know, but maybe, no, more than that. It's my just guess. Okay, how about my 7-year-old son? I really love the construction machines like excavator and bulldozer and the, let's say there is some specific excavator. Can you guess how much of these are sold? Maybe around somewhere between here. So, well, the important thing is some of the excavator model is really expensive and can be comparable to that one, because company owns it. Okay, question. Um, let's say you're the manager and owner of your F1 Grand Prix team. What would be the processes of manufacturing your F1 Formula car? Job shop? I think it's only one project, right? Project. So I'd like to ask, what's the difference between project and job shop?
Scale is project is bigger scale than the job shop.
Scale?
I think, but the job shop is
Project is for the one time only. You do a class project. Are you doing that same thing again and again and again? No, you just don't do that project only once. It's for the project. If you have a sister car or something, then it suddenly become a job shop. Okay, so for example, Lamborghini, maybe. To make our problem more simpler, let's make it more, no, Lamborghini something limited edition. So only 50 are sold per year. If you're producing 50 Lamborghini per year, then is it a project or job shop or batch?
I think
It's a batch.
is
Why?
job shop and batch process is similar because um, both are produced once customer demand increase, but the batch process is produce a limited quantity of it.
Yes, limited quantity.
But the job shop is produce continuous, but the size is smaller than that.
So is the point is the size differences. Yeah, could be halfway through, and I think it's more about the variability. For example, um, when we talk about 50 Lamborghini per year, do you think that all the colors and options are exactly same for all these 50 Lamborghini? Heck no. Color will be various. Option is different from one to another, and some is you know some has the manual transmission, some has automatic, and some has some control, and the engine displacement could be different, and many variability will be there out of 50. Do you think it's a skill job shop? What is it? Yep. Project. So project only one time. But you are producing 50 different, very similar products. It's more like a job shop. There is uh, a decent amount of flow volume compared to the project, and the routing of the workstation, the part flowing between the workstation is varying in job shop. If you flow exactly same workstation, then it's more like a batch. So as I mentioned before, at the beginning of the class, there is no clear cut, but it's more like job shop. Okay, when you go to Sonata, you may think it's a line flow without any question, right? Do you think it's a line flow? What then? Yeah, Sonata. Yeah, yeah. Okay. For the Rambo, what's the question?
This is a level is a job shop. Understood. But if throughout the year we actually produce one Lamborghini at one time, then after finishing it again we actually produce another Lamborghini, and throughout the year we produce 50 Lamborghinis. Then it will be a job shop or
Okay. Question. Okay, I understand, and very good point. But if you think of this Lamborghini, let me ask: 50 unit per year. Cycle time is about week, right? And what's the lead time then? We don't know, but based on our common sense, it could be 6 months or so, or 3 months or so, right? To manufacture a Lamborghini, you need a decent amount of time, couple of months or so, right? Okay, which means your production is sometimes overlapped to each other. Okay, then the job shop. As you pointed out, if to make a Lamborghini, it takes about a month, and you're producing 2 Lamborghini per year, then it could be 2 consecutive projects. Okay, but there is always a flow, but this routing line are just moving differently. So It's a key point of the job shop. And for the batch, well, for the automotive production, well, everything is more about around here or job shop. You know, for excavator, it's a job shop. That's the type of the industry because it's too heavy and everything is built to order based on, you know, well, and can you think of any batch produced products? It's everywhere. Batch is think of a lot in front of some workstation. The reason to use a large amount of inventory in front of that workstation is that the process in that workstation is really, really fast. So you don't want to starve that machine. You want to run that machine all the time. So that's why you put a large amount of inventory, which is a batch. And once everything is done, and during that process, you don't have to change the tools or set up the machine. Okay, that's the typical characteristic of a batch. Can you think any batch produced product? Instrument? In here, page number 3. Okay. Mm-hmm. Musical instrument. Yeah, right. Okay, that's a correct answer, but I'd like to hear your own language from your own knowledge. So, any batch production product?
So, medical products statistics.
Okay, and and any other? Yeah, yeah, right. Probably. If you go into, out of a car, there is a large spectrum. So if you're talking about a very expensive and very complex and automatic massaging machine or something, then the chair is around job shop or something. But this kind of thing is, I think it's a batch. Yeah. Yeah.
If F1 produce only one per year, but next year also produce F1 of modified.
Sorry. This is misleading. Not per year most of the time. Single. Okay. Any batch example out of your experience? Well, yep. Chair and table. Yeah, nice try. Yep. The characteristic of this batch production is that, as I mentioned, there is a very highly automated workstation is involved, and you don't want to starve that machine. So you put a large amount of inventory in front of it, and you move that inventory one by one. So for some part of the automobile assembly line, there is a large batch processes are moving on. For example, if you're working in front of the door panel stamping station, you don't just stamp one thing and deliver it to the next workstation. You actually get tens or 20 or 30 door panel and stamp and stack it, and once this batch leg is filled, and you move that batch leg into the next workstation. Okay, so actually, if you go into more detail, you can find many batch type of processes in every job shop, sometimes project or sometimes line, or it's everywhere. Okay? If you're moving batch, then it's a batch production, basically. Okay, I don't think I need to explain this line and continuous process, but okay. Bottom line is there is a spectrum of these processes, so there is no clear cut. Everything can be mixed to each other with adjacent production systems, and there are many aspects to determine this best processes to choose, production characteristic and units and other things. Okay, and please keep that in mind that everything is chosen because it's the most economical. But in reality, you also have to think something more, human factor and cultural thing. That's this type of processes. So I really want you to truly understand all these parts, because in later of these courses, I'm now preparing the term project, which will be done by team of you guys, and it's about shipyard. You guys are supposed to design a shipyard. How do you design a shipyard? First, we got to know the product. What's the product? Well, ships of some type. This kind of ship, and more for sometimes, let's say like that. There is what we call product mix. For example, in our shipyard, well, 30% we produce container ship, and 20% we produce oil tanker, and rest of them we are producing drilling ship or something like that. Those strategic planning, the result of that planning is product mix, what we are going to produce. Okay, we know the product. Then and we know the characteristic of this product. You know, how many curved blocks are required, how many machineries and pipes and hulls are required. We will going to do that in analytical way, and based on that information, we have to choose the relevant processes. The required processes we already know. We reviewed it at the beginning of the classes. The ship is produced from stockyard, surface preparation, primer, cutting, marking, until it is outfitted and sea trialed. Okay, we know the required step. The next thing is, based on each intermediate product's characteristic, we got to choose the right kind of processes. Okay, once you choose the right processes, the required information will be derived. For example, in order to produce this much of product mix could be translated into 10,000 ton per month or so. In order to deal with those kind of amount, we need this much amount of stockyard area, and based on that, we can estimate the required area of each workstation we choose, and then we cleverly arrange those required the workstation areas into the given shipyard layout. And based on that, we can begin to design the shipyard from the scratch. So keep that in mind. Okay, let's continue on this model. In previous class, we talked about this a little bit modified EOQ model. This is time. This is reorder point. So reorder point means when this inventory level is decreasing, and when reaching your reorder point, you actually put the order to refill your inventory. But however, this is no instantaneous delivery. You need some kind of time. And this slope is based on this usage rate, D, and this slope is because of production rate minus usage rate. So, based on this modified EOQ model, I said the optimal order quantity is given as similar to original order quantity model. Okay, let me give you some virtual example to explain this more. Let's say there is a part X, X1. Okay? This part X1 is produced 100 units per day. And used in assembly line 40 units per day. Okay, based on the definition, D is daily usage rate. The definition is how much this part is being used per day. And what's this D? 40, yes, 40 unit. Okay. Okay. P is production rate. Per day, so it's 100 units. And for the illustration proposed, let's assume large D is annual demand. It's a 10,000 unit. It's assumed based on this equation. We are using 40 units per day, but in a year, usually the working days is about 250. It's assumed based on this equation. Okay. Similar to original EOQ model, the cost for production setup is, for now, assume that it's a $50. Okay. H is also same. Annual holding cost. 5 cents per unit. And let's say this non-instantaneous delivery. Lead time let's say this is 1 week. Okay, what do you see? For this part X1, demand is 10,000 units per year. We have to produce 10,000 units per year because it is used by the next assembly line 40 units per day. And production rate is, if we order, we need more part X1 than the previous workstation. They can produce 100 unit per day. So basically, it is working because the production rate is higher than the usage rate, right? If this is vice versa, then this production system doesn't work, right? You get the point? Okay. So there is some point, reorder point R. Our inventory level we are considering about this Q, and production rate 100 units per day is about this workstation. 40 units per day is about this workstation. It's not continuous. When we have enough inventory, our workstation here will not get any order from us. Okay? When we give the order to the front workstation, then it requires lead time, and once the lead time is reached, it's going to fill. What's the slope of that? It consumes 40 units constantly, however, it's filling 100 units constantly, so it's a 60 per day. What's going to be this slope? -40. Actually, -40 per day. So you get the idea? at this reorder point, if this delivery is instantaneous, and which means there is no lead time, if we put a reorder here, then instantly Q star will be arrived, and then this inventory is consumed by this daily usage rate like this. But however, they need a lead time, so it's not instantaneous. And also when they are supplying our inventory, at the same time it is used by this. So that's why we have this kind of a slope. And once the order amount is supplied by the first workstation, then there is no more order. So after that, it is decreased like that. That's this diagram. So you get the point? Okay. Based on this equation, when we are in this kind of system, this Q star, economic order quantity is exactly like this. A times D. What's A? What's D? What's H? Do you have the lecture note about EOQ model? Is this correct EOQ model? I'm just confused. Isn't there number 2 somewhere? EOQ. EOQ model. EOQ model. Do you have a lecture note, EOQ? Have to check. I don't remember. But in my lecture notes, I didn't use number 2 here, but in my calculation, I used number 2 here. So that's why I'm confused. So please check. And maybe there is number 2 somewhere here. Anyway, based on the calculation, it's about so economic order quantity is about this, not this peak. This virtual peak is 1,826 units. And what is R then? Well, you know the slope and you know the L. Then you can calculate this R. It's nothing more than just D times L. 40 times 7. So the thing is like that. If our part X1 batch behaves like that, it's a little bit more relieved model compared to the original EOQ model. But anyway, when your inventory level of the X1 reaches 208, then you have to put order. How much? This much of order. Then this system is most economic. Question?
What happens if the production data instead becomes
What?
equals to equality indication
Indication. There is a
equality. If P equals T, it's not
P is equal to. Ah, okay. Good point. As I mentioned here, I said 100 is larger than 40, so it is possible. But what if this is exchanged? This production system cannot work. You're consuming 100 per day, but feeding is 40 per day, then that's the end of the story, right? What if you consume 40 per day, but your input is 40 end of day?
it can still work.
Yep, it can still work, but not for this. It's a model. So you pointed out the continuous one, right? That's the Toyota production system is aiming for, but not this case. It's a model, so we assumed a very nice thing. So, but you pointed out the out of border, so it will not work. Based on that, also based on this equation, if this is exchanged, you will see minus sign under this root. If you want to calculate those kind of things, you have to use another model. Yeah. Okay. All these A and H and D these are for the EOQ model. Derivation of everything is exactly same as this EOQ model. Okay. Question? It will be a nice trick, but it is worth your time. You know, in the original EOQ model, we did our own assumption and we derived how we construct the total cost. Total cost equal to setup cost plus inventory cost plus, yep. And you can do the exactly same thing here with this a little bit different model. And the derivation of this is, the process is exactly the same. You take the derivative and you just calculate the minimum. You calculate what's going to be the minimum of that equation using the differentiation. You will get that. Another thing is you can still improve this model a little bit by little bit using exactly same approach. Like what if this is not fixed? We said this is fixed, 40, constant. But life is not like that, so we can substitute D with average demand and standard deviation of that demand. Sorry, this is going to be L. L is fine. Derivation is exactly same. You can exchange it, the component, but you can easily derive this model as well. And this is their own model name. Fixed order quantity model with specific service time. And actually, if you browse many of these related textbooks, you can see hundreds of this kind of model. Okay. But the basic derivation process is exactly the same. And if you get interested enough, you will put some more efforts to observe some characteristic processes in a shipyard, and you can derive your own economic order quantity model based on some specific characteristic. And actually, even nowadays, many doctoral students or master students are developing their own lot sizing models as well. It's still possible. Okay, so far we talked about this economic order quantity model, and this is about steady state, static, quasi-static state. But now I'm gonna introduce dynamic one. Okay. Okay. Let's review the EOQ model assumption. In EOQ model, we made these assumptions. Instantaneous production, immediate delivery, deterministic demand, constant demand, known constant setup time, single product, or separable products. These are the assumptions. Instantaneous production, right? If we relieve these two parts, and instantaneous production and immediate delivery, if we just relieved this assumption number one, so that becomes there is a now non-instantaneous product. Okay, production rate dependent, immediate delivery. But in the next model, in second model, we assume the lead time. So by doing that, we relieved the number two assumption. Deterministic demand. Okay, we stick to it, but introducing this, there is a way to relieve this number three assumption. Constant demand. That's a key point. Known constant setup time. Well, for now, let's leave it there. Single product or separable product. What does that mean? In our EOQ model, we are dealing with only one product, one type of product. We are not thinking of any several type of product at the same time. Or even though we are producing several product, these products are not interrelated with each other. It's separating. So if we look one product by one product, it's just a single product. No interaction with other product. Okay? It's just a very strong assumption to make our problem more simpler. Okay? The dynamic lot sizing problem, we relieving some of this assumption. Among this assumption, we are relieving the assumption number 4 by introducing these dynamic terms. Okay? What's so dynamic? Well, think of this dynamic property and have to careful in thinking. We are not about thinking about this number 3. It's just still deterministic. So my question is, what's the big deal then? We know that what is deterministic and at the same time constant. We know what that is. Okay, then what is the deterministic but not constant demand? Is it possible? Yeah, of course. And what would that kind of be? Since we already said it's a deterministic, no random or no stochastic demand, but not constant. It's a varying, but it's a deterministic. Can you guess what that case is? Yes. Mm-hmm. Yep. Yep, right, exactly. Thing is like that. This is time. And for this EOQ model, we define some D as a constant and deterministic, since we know the value. Here, same. But for dynamic lot sizing, the D can be non-constant. But we know the value. So it's a deterministic but non-constant. How we can deal with this? That's all about dynamic lot sizing. You know, in real world case, actually the demand is not deterministic. We don't know. But we can forecast with higher probability. By doing that, we can transform this unknown demand into some deterministic number. But this forecasted deterministic demand is not constant. So this dynamic lot sizing is much more closer to the real world problem compared to the EOQ model. And as classes proceed, we are also approaching to the real world problem step by step by relieving the assumptions. Okay, time's up. So we will continue on this dynamic loss sizing from the example next class. Thank you.